Hey everyone, welcome back to another deep dive. Today we're jumping headfirst into the world of industrial process simulation, where things are getting seriously fast and efficient. Buckle up.
Yeah, it's amazing stuff.
We're talking about a brand new system called NeuralDEM.
Hmm.
It's using the power of deep learning to predict how materials behave when you've got a whole lot of them. I
Uh-huh.
think mixing cement, designing pharmaceuticals, stuff like that.
Really, a whole range of industrial processes. Traditionally, simulating these things meant tracking every single particle,
Right.
which takes forever, even with supercomputers.
I can imagine.
It's like trying to analyze a giant container packed with millions of tiny grains, all bouncing around,
Oh, wow.
each one interacting with the others.
Yeah, like trying to map out every single interaction in a bustling city, right?
Exactly. That will take, well, ages. But NeuralDEM offers a pretty neat shortcut.
Interesting.
Instead of getting stuck on those individual interactions, it looks at the whole system as a continuous field, you know?
Okay, so like looking at the overall flow of traffic instead of tracking each car.
You got it. That's a great way to think about it.
So that's how NeuralDEM can make predictions about how the whole system will behave way faster than the old methods.
Much faster.
And it's still accurate, even with, what, hundreds of thousands of particles.
Even more, yeah.
Amazing. So how does NeuralDEM learn to do all this?
Well, it's all about training.
Oh, okay.
It learns from a massive amount of those super detailed traditional simulations.
Ah, so it's like it's got this virtual mentor?
Exactly. It's picking up on those hidden patterns, those relationships between particles that we might not even notice ourselves.
So it's like NeuralDEM is going to school for particle physics, but it's learning at warp speed.
I like that.
The research paper mentions a multi-branch system.
Right. That's one of the really cool things about it.
What is that exactly? Sounds kind of like a sci-fi tree with special powers or something.
Well, maybe not quite a tree, but think of it like NeuralDEM has different branches, each one specializing in a certain part of the simulation.
Okay.
There are main branches.
Gotcha.
Those handle the core physics, like how particles move and interact or how fluids flow, kind of like the trunk of the tree.
Right, the foundation. Yeah, that makes sense.
And then you have these off branches.
Mm-hmm.
They answer those specific questions you might have about the system, like how well materials are mixing or how long it takes for something to flow through a certain structure.
Ah, so like the leaves of a tree reaching out to capture sunlight from different angles.
That's the idea. Each branch contributes its own expertise.
And all those branches are talking to each other, right?
Yeah.
Sharing information to make sure the simulation is as accurate and complete as possible.
You got it. That's what makes NeuralDEM so powerful.
Okay, that's a great explanation. I'm really starting to get it.
Good.
Now let's talk about some real-world examples because this is all very theoretical.
Sure.
The researchers put NeuralDEM to the test on two very different case studies.
Yeah.
The first one involves things called hoppers.
Mm.
You know, those big containers you see at construction sites or factories that hold sand, gravel, all those materials.
Exactly.
Essential for lots of industries.
Absolutely. And NeuralDEM gives us a whole new way to understand and optimize them.
Okay, I'm intrigued. So what kind of insights can NeuralDEM provide about hoppers?
Well, it can predict a bunch of important factors, like how much material flows out at any given time, how long it takes to empty, and even how much material gets stuck inside.
Wow, that's useful.
Imagine being able to prevent those annoying clogs that can really slow down production.
Yeah, that's a big deal. I read something about predicting different flow regimes.
Right.
What does that even mean? Like the material does a little dance inside the hopper.
Well, not quite a dance, but the material can definitely behave differently depending on various factors. Think about pouring sand through a funnel.
Okay.
Sometimes it flows smoothly, like water, and other times it clumps up and gets stuck, right?
Yeah, I've definitely experienced that frustration before.
NeuralDEM can actually predict which type of flow will happen.
Really?
Yeah, so engineers can know exactly what's going on inside the hopper.
It's like having X-ray vision for your hopper. See what's happening and avoid those problems.
Exactly. It can save a lot of time, money, and headaches.
Now, there was one more fascinating detail about hoppers.
Mm-hmm.
Something about residence time.
Oh, yeah, that's really cool.
What is that exactly?
Imagine you could track how long each individual grain of sand spends inside the hopper.
Oh, wow.
Like a tiny little GPS tracker on each particle.
That's incredible.
NeuralDEM can predict that. It can tell you the residence time of individual particles.
So we're not just seeing the big picture, but we're getting a microscopic view of what's happening inside this huge system.
Right. And the cool thing is that NeuralDEM can even handle those situations where the hopper is constantly being refilled.
Which is more realistic, right? Like in a real-world setting.
Exactly.
So it can adapt to those changing conditions.
It can.
Yeah, it's pretty impressive.
It's a real game changer compared to the traditional methods, which struggle with that kind of complexity.
Okay, so we've seen how NeuralDEM can tackle hoppers. Let's move on to case study number 2, which involves something called fluidized bed reactors. I'll admit I had to brush up on this one.
Sure.
Could you give us a quick rundown?
Imagine a reactor where gas is pumped through a bed of particles, creating this super dynamic, complex flow. It's like a bubbling cauldron where particles are swirling around as the gas flows through.
Okay, I'm starting to get the picture.
Good.
But why are these fluidized bed reactors so important? Where are they used?
Oh, they're used all over the place. Chemical production, pharmaceuticals, even energy production, to name a few.
Wow, so simulating these systems accurately must be super tricky.
It is, yeah.
You've got the gas and the particles all interacting in these crazy ways.
It's like trying to predict the weather inside a tornado.
Okay, that sounds like a computational nightmare.
It's quite a challenge. But NeuralDEM is up to the task.
So how does it handle this multiphysics madness?
It simulates both the fluid, the gas, and the particles at the same time. Captures how they influence each other.
Oh, wow.
And get this, the researchers even pointed out a cool visual detail that NeuralDEM can reproduce.
Ooh, visuals. I love a good visual. Tell me more.
Imagine you could see those bubbles forming and moving inside the reactor. Well, NeuralDEM can recreate that visually.
Seriously?
Yeah, it's like watching a mini documentary of what's happening inside.
So it's not just about the numbers, but you can actually see how these systems work in action.
Exactly. It brings it to life.
Amazing. Now, does NeuralDEM keep up with all this swirling and bubbling? Is it accurate over, longer periods?
Does, yeah.
The researchers found it produced super stable and accurate predictions, even over those extended periods.
They did, yeah.
And remember, it's doing all this way faster than traditional methods. It's like the best of both worlds, speed and accuracy. Did anything else stand out about these fluidized bed reactor simulations?
Well, this is particularly interesting for anyone working with these systems. NeuralDEM can also predict how well materials mix inside the reactor.
Oh, interesting.
You can optimize mixing without running those expensive experiments.
So it's like a virtual mixing bowl where you can test things out and see what works best.
You got it.
Okay, we've covered a lot of ground here with hoppers and fluidized bed reactors.
Yeah, we have.
So, stepping back a bit, what are the key advantages of NeuralDEM compared to the traditional way of doing things? Obviously, it's much faster.
Speed is a huge one.
But what else?
Well, traditional methods often need super specific particle properties, right?
Yeah.
NeuralDEM doesn't.
Oh, interesting.
It can work with more general measurements, like the friction angle of a material, which is easy to get from a simple test.
So it's making these simulations much more accessible to researchers and engineers who might not have all that super detailed particle data readily available.
Exactly.
And it's more flexible too, right? Because of that multi-branch structure.
Yeah. Right. You can tailor it to answer specific questions about your system, whatever they might be.
So we've got speed, accessibility, flexibility. It's the ultimate simulation tool.
Yeah.
But there's got to be some limitations, right? Nothing's perfect.
Well, every new technology has room to grow, and NeuralDEM is no exception.
Okay.
While it's powerful, it's not flawless.
Makes sense.
For one, some specific particle properties are still tricky to model perfectly. And as you make the simulation bigger and more complex, you'll need even more data and computing power to keep up.
That's understandable. It's like trying to map out this vast unexplored territory.
That's a good way to put it.
You need more resources as you go further.
Exactly.
Okay, so where does NeuralDEM go from here? What's next for this game-changing technology?
Well, the future looks bright, that's for sure. Future research will probably focus on tackling those limitations, like modeling those tricky particle properties with even more accuracy.
So making it even better.
Yeah.
Okay, I'm excited to see what they come up with. This has been a truly fascinating deep dive.
Glad you enjoyed it.
I feel like I've learned so much.
Me too.
And it's just the tip of the iceberg, right?
Oh, absolutely. This is just the beginning.
This NeuralDEM thing has got me hooked.
Great. Happy to share this kind of groundbreaking stuff with a curious mind like yours.
Well, keep it coming. I'm ready for more.
Okay. Let's keep diving in. And the really exciting part is we can start incorporating even more complex physics into these simulations, things like heat transfer, chemical reactions, all that stuff that happens in real industrial processes.
It's like taking NeuralDEM to a whole new level, right?
Exactly, making it even more powerful and realistic.
Imagine simulating a chemical reaction happening inside one of those fluidized bed reactors in real time. Seeing how the temperature changes, different substances interact.
It would be incredible.
We could optimize those processes in ways we can only dream of right now.
It would be like having a virtual laboratory where you can experiment and innovate without any of the real-world risks.
Yeah, no explosions, no accidental chemical spills.
Yeah. Exactly. It's all about pushing the boundaries, designing more efficient and sustainable solutions.
So we've established that NeuralDEM is a total game changer, but I'm curious about the nitty-gritty. How did the researchers actually train and test this system?
It's a deep learning system, so it's like training a student.
It needs lots of practice to learn the ropes.
Precisely. So they trained it on this massive data set, thousands of those highly detailed simulations we talked about earlier.
Oh, wow.
Covering all sorts of parameters and scenarios.
See, it's like NeuralDEM is cramming for a PhD in particle physics.
Haha, I like that analogy.
But instead of years of classes, it's crunching through simulations at warp speed.
Exactly. And to test its knowledge, they gave it those 2 case studies we discussed, hoppers and fluidized bed reactors.
Right, the real-world challenges. How did it perform?
It passed with flying colors.
Nice.
For the hoppers, it accurately predicted things like the outflow rate, drainage time, how much material got stuck, all that stuff.
It even captured those different flow regimes, right? Like the smooth flow versus the clumpy flow.
It did, yeah. Which is impressive because it's essentially learning to see those subtle differences in how the material behaves just from the data.
So it's like it's developed this intuition for particle dynamics.
You could say that.
And for the fluidized bed reactors, it nailed the simulations too, right?
Yep. Both the fluid and the particles interacting accurately, even those visual details like the bubble formation.
Amazing. And all of this in a fraction of the time it would take a traditional simulation to run.
Exactly. That's what makes it so groundbreaking.
Okay, so NeuralDEM is fast, accurate, versatile. But let's bring it back to our listener for a second.
Sure.
Let's say you're working in an industry that uses these kinds of processes. What does NeuralDEM actually mean for you on a practical level?
Well, imagine being able to design and optimize those processes much faster than you ever could before.
Okay.
Instead of waiting hours or days for a single simulation, you get results in seconds or minutes.
That's huge.
It's like going from dial-up internet to fiber optic broadband.
Right. It completely changes the game.
And that speed allows for a much more iterative design process. You can experiment with different configurations and see the impact immediately.
So it's a real-time feedback loop, basically.
Precisely, you can fine-tune things and find the optimal solution much faster.
Leading to cost savings, better products, maybe even a reduced environmental impact.
Exactly. It's not just about speed. It's about making the whole process smarter and more efficient.
So NeuralDEM is like giving engineers a superpower.
I like that. And remember, it's still early days for this technology. As it matures, the potential applications are limitless.
It's like we're witnessing the birth of a new era in industrial process simulation. An era where these complex simulations aren't a bottleneck anymore, but a catalyst for innovation.
I couldn't agree more. And the exciting thing is that this kind of technology isn't limited to traditional industries.
Oh, really?
It has the potential to revolutionize fields like medicine, material science, even climate modeling.
So it's like a universal tool for understanding complex systems no matter what the application.
Exactly. The possibilities are mind-blowing.
Okay, before we get too carried away with the future, I want to bring us back down to earth for a moment.
Sure.
The researchers were very upfront about the limitations of NeuralDEM. What are some of the challenges they highlighted?
Well, one of the main limitations is its reliance on data from those traditional DEM simulations.
Right. It's still learning from its mentor in a way.
Exactly. And that means it can only simulate systems that have already been simulated using those older methods.
So it still needs that foundation of knowledge.
It does. And another limitation is that it's mainly focused on the macroscopic behavior of these systems.
Okay.
It can't yet accurately predict the behavior of individual particles.
So it's like seeing the forest, but not being able to identify each individual tree.
Precisely. And that can be a problem for some applications.
Right, because sometimes those tiny details matter a lot.
They do.
Okay, so there's definitely room for improvement and further development, but that's part of what makes this field so exciting, right?
Of course, there's always more to learn and explore.
It's exactly. The researchers suggested a few directions for future work. What were some of those?
Well, one idea is to make NeuralDEM less reliant on those traditional simulations.
So to give it more independence, more ability to learn on its own.
Exactly, maybe by developing new ways to generate training data or incorporating other types of data like experimental data.
It's like giving it a broader education, exposing it to a wider range of information.
That's a great way to put it.
What else?
Another focus is improving its ability to predict the behavior of individual particles.
So to give it a more microscopic view, zoom in on those details.
Exactly. And of course, there's always the potential for incorporating even more complex physics into the system.
Okay, so they're basically giving NeuralDEM a roadmap for its future education.
Uh-huh.
You could say that. And as it continues to learn and evolve, it could truly revolutionize how we design, optimize, and understand all sorts of processes.
It really could.
It's like we're seeing a paradigm shift in how we approach these complex systems.
I agree. And this research really shows the power of deep learning to tackle some of the toughest problems out there.
It's like deep learning is giving us a new set of eyes, helping us see the world in a whole new way.
Uncovering hidden patterns and making predictions that were once thought to be impossible.
Exactly. And with those new insights, we can unlock so many possibilities for innovation and discovery.
It's an exciting time to be alive.
I completely agree.
Yeah.
I'm feeling inspired to learn even more about NeuralDEM. Where can our listener go to dive deeper into this research?
Well, the researchers have a project page where they share more details.
Perfect.
We'll include a link in the episode description so you can check it out.
Awesome. And for our listeners, if you're as fascinated by this as I am, definitely explore that project page. It's a treasure trove of information.
I encourage everyone to dive in and explore. You might just discover your next big idea.
Well said. I think we've given our listeners a pretty solid overview of NeuralDEM and its potential. But before we wrap up this deep dive, I want to leave you with something to ponder.
Okay, I'm listening.
The researchers mentioned that one of the key advantages of NeuralDEM is its ability to generalize.
Right. It can learn from one type of system and apply that knowledge to a different but related system.
Exactly. It made me think, what if we could develop NeuralDEM to the point where it could generalize across even broader categories of systems? What if it could learn from simulations of physical systems in general, not just particles, and then apply that knowledge to completely different domains?
That's a fascinating thought.
Right.
It's like developing a universal simulator.
Exactly. A system that could predict the behavior of anything, from fluids and gases to living organisms, even social networks.
It might sound like science fiction, but who knows? With the pace of AI advancements, it might not be as far-fetched as it seems.
I know, it's mind-blowing to think about.
The potential is limitless, and that's what's so exciting about this research. It's not just about solving specific problems, it's about expanding our understanding of how the world works.
It's about developing tools that can unlock new levels of knowledge and innovation.
Exactly.
And that's what the deep dive is all about, taking a deep dive into these breakthroughs and exploring what they mean for the future.
Well said, and I'm sure our listeners will join us in eagerly anticipating what the future holds for NeuralDEM and the field of real-time simulation. It's going to be an exciting ride.
Absolutely. So if this deep dive has sparked your curiosity, we encourage you to check out the project page. We'll link it in the episode description. You'll find more details about NeuralDEM and the team behind it.
And as always, stay tuned for future episodes of The Deep Dive, where we'll continue to explore the cutting edge of science and technology.
Until next time, keep those minds curious and those imaginations firing. It's like we're giving NeuralDEM this superpowered upgrade, right?
Yep.
Pushing the limits of what's possible in simulation.
And with those advanced capabilities, who knows what we could achieve? We might be able to design entirely new materials with unique properties, or even develop hyper-efficient energy systems, the kind that could revolutionize how we power the world.
It's like NeuralDEM is opening a door to a future that right now we can only imagine. But before we get too ahead of ourselves and start dreaming about the future, let's bring it back to the research for a minute. One thing that really struck me about this whole thing was NeuralDEM's ability to generalize.
Right.
So it can learn from one type of particle system and then apply that knowledge to a different one. It's like it's extracting those underlying principles, right?
Exactly, those fundamental rules that govern how these systems behave. even if the specific details are different.
Exactly. It's like, I don't know, learning to ride a bike. Like once you've got those basic skills, you can apply them to different bikes, even if they've got different gears or frames.
That's a great analogy, and it makes you wonder, what if we could push this even further? Could we develop NeuralDEM to a point where it could generalize across even broader categories of systems? Imagine a system that could learn from simulations of physical systems in general, not just those limited to particles, and then apply that knowledge to totally different areas.
Okay, now that's a really mind-blowing thought. Like having this universal simulator.
Yeah.
Something that could predict the behavior of anything from fluids and gases to living organisms, even social networks.
It might sound a little like science fiction, but who knows? With the speed that AI and machine learning are advancing at, we might be closer to that reality than we think.
It's exciting and a little bit daunting at the same time, isn't it? This research really highlights how quickly things are changing and how it's pushing us to rethink what's even possible.
I agree. It reminds us to stay curious, to keep exploring and pushing the boundaries of knowledge. Who knows what amazing breakthroughs are just around the corner?
Well, that's what the deep dive is all about, right?
Yeah.
It's exploring those breakthroughs, diving into the research, and trying to understand what it all means for the future.
Exactly. And I'm sure our listeners are just as excited as we are to see what the future holds for NeuralDEM and for the whole field of real-time simulation. It's going to be an exciting ride.
Absolutely. So to our listeners, if you're as captivated by this as I am, we encourage you to check out that project page. We'll link it in the episode description. You can find out more about NeuralDEM, the team behind it, and all their research.
And of course, if you're hungry for more deep dives into the world of science and technology, make sure to subscribe to the Deep Dive. Join us on this journey of exploration and discovery.
Until next time, keep those minds curious and those imaginations firing.